Peyton, did you see the other error that was in the proportional change video?
Oh, wait, no.
Hey, are you recording?
Adam?
They forgot to put the decimal point.
Okay, so they
Oh,
did
yeah, I did have that written down.
3, and then they put the decimal in the wrong spot. So you picked that out. That's good. Now, the reason that they like to put errors in the videos is so that if you pick it out, then you really have a deeper understanding and you know what's going on. So let's look at the proportional change of volume. The first thing I want to do is I want someone to tell me what's the formula that you're going to use for proportional change of volume. Ava?
The old volume times the scale factor cubed.
Okay, so the old volume, so you want to write this on your paper, times the scale factor cubed equals the new volume. Okay, there are a couple of ways that you can find the volume. You can do it by each dimension, or you can use the formula. For example, here we have a cube. First of all, we want to find out what is the volume of this cube. 1 times 1 times 1 is 1. So the volume of this cube is 1. Now we want to look at this cube and we want to find out what is our scale factor. What do we multiply by 1 to get to 2? Times 2. So our scale factor is 2. So when we get our scale factor of 2, that is the scale factor, we can come over here and we can find out what we're going to use to find our volume. We can say 2 times 2 times 2 because we have to cube the scale factor. So 2 times 2 is 4 and 4 times 2 is 8. So that is our scale factor there. Now we can go back and we can find our dilated figure. And remember, dilations refer to anything that's bigger or smaller. So our dilated figure, 2 times 2 times 2 is 2 times 2 is 4, and 4 times 2 is 8. So the new volume of our dilated figure is 8. We can take our formula that we have right here, and we can say that old volume, 1, times the scale factor cubed, which we know is 8, gives us 8. So our new volume is 8. Just like we see here when we did it by each dimension. Okay, now we're going to come back to the cylinder, but let's go ahead and do the rectangular prism. The first thing we want to do is say 1 times 3 times 2 is what? 6. So the volume of the original figure is 6 cubic units, and we can find out, how do I get from 1 to 4? What is our scale factor? 4. So our scale factor is 4. So I can come over here and I can say 4 cubed, 4 times 4 is 16, and 16 times 4 is 64. So that is when we get our change in volume, we can use the 64. So I can go and I can take my original or my old volume, 6 times 4 cubed, or 6 times 64, and I get, add that down.
384.
So I get 384. I can also come over here and say 4 times 12 times 8, and I get the same answer there. Now let's look at our cylinders. We have a diameter of 4 here and a diameter of 12 here. How do I get from 4 to 12?
3.
Okay, so times 3. So I can take my scale factor of 3, and I can say 3 cubed, 3 times 3 times 3. So 3 times 3 is 9, and 9 times 3 is 27. And I can use this, and I can take my old volume, which we haven't figured out yet because cylinders are a little bit more complicated, so let's go figure this out. The volume of a cylinder is that capital B, which is the area of the base, times the height. Now remember, capital B is pi r squared. So I can say 3.14 times the radius. Well, if our diameter is 4, our radius is 2. So 2 squared is 4. So 3.14 times 4
12.56.
So I'm gonna round to 12.6, that's our capital B. I'm gonna come over here and I'm gonna say 12.6, that's the area of the base. The height is 2, we see that. So 12.6 times 2 equals 25, I believe. Okay, we can round to 25. So then I can take this original or the old volume, 25, and I can say 25 times 27, or that 3 cubed, and I get 678, right? Or 675, something like that. Okay?
Miss Sarah,
Uh-huh.
instead of, wait, did you square the 2 in parentheses, wouldn't it be 12.6 by 4?
This is the, right here, the height, so we did that.
I did
No, no problem. Okay, let's give us some more room, because now we can also check it. Let's check it with this figure here. So remember, volume is the area of the base times the height. Remember, we have to do pi r squared. So here we have a diameter of 12, so our radius is 6. So 3.14 times 6 is 36. So somebody go ahead and do this. 3.14 times 36.
113.
113, that's our capital B. So I'm going to come over here, 113 times the height, which is 6. What do you get when you do that?
678.
678. So that's pretty close to the, I got 678 doing this. It could be, somebody else had 675 earlier. But as you can see, you can do it by using your scale factor and changing every dimension, or you can use the formula, as long as you realize the scale factor is what the original thing is. This is doubled, tripled, quadrupled. This is after you've cubed it. You get that and you can use this formula. Now, what relationship do you notice when you did this? Chase?
Scale factors are plus.
Do what?
The scale factors are all like +1.
Okay, so the scale factor is always cubed. That's what we notice the pattern. Mackenzie?
Oh wait, what was I gonna ask? Oh yeah, how come the whenever we like change the dimensions and the other, like whenever we did the formula, how come they were different?
We get the same answer. It was only because when we did the 3.14 and we rounded a little, we just got a few numbers off. So we're pretty close. Peyton, did you have a question?
No, never mind.
Okay, so do you see, you can do it either way. I had somebody today they said they prefer to change each dimension, and I had somebody today said they prefer to use the new volume, this formula. So go ahead and get started on the next few problems. Cross off number 8 on those problems and work through those, and then I'll come around and check and make sure that you are getting those correct.